Cool. Hi, everyone. Welcome to the community meeting for March. So today we have a bit of a short agenda. First, Anush is going to give us some updates on new workloads Node has been able to run using Torch-MLIR. And then Prashant will go over a method that he has been using for extracting float 16 graphs using PyTorch CPU. For those not familiar with the issue, there's very little support for float 16 ops on PyTorch CPU. So if you want a graph with float 16 tensors flowing throughout, you usually need to use PyTorch plus CUDA. So this method of circumventing that limitation is very useful for people who cannot install PyTorch plus CUDA. So that should be really interesting. But before we get into that, a few reminders. So our community meeting takes place the first Monday of every month at 9 a.m. Pacific time. That's this meeting. The goal here is to give a high-level overview of the main changes happening in Torch-MLIR. All other Mondays, at the same time, we have our developer hour. This is not a recorded meeting. There's no agenda. And it's a great place for people to come and ask questions or bring up new ideas for things that they would like to have in Torch-MLIR. Additionally, every Thursday, there's office hours from 8:30 to 9:30 a.m. Pacific. That's hosted by me. And this is more for entry-level questions or debugging Torch-MLIR patches. Lastly, we have our Discord. It's a pretty active Discord, so if you want to stay up to date with the latest things going on in Torch-MLIR, make sure to join that. Here are some statistics of the last 4 weeks. So we had a total of 37 commits, and these commits, they touch almost every corner of Torch-MLIR. So thank you so much for all the people who have been working on the contributions. This is a list of the new ops and improved ops in Torch-MLIR. Many of these were actually decompositions, which is quite nice because that means they essentially have a 3x impact since they work on all 3 backends. So thank you everyone who worked on these. And now I will hand it over to Anush to tell us a little bit about what he has going on.
Cool. I think from the workload side, I think we've been tracking Stable Diffusion for a while. About a month, 6 weeks ago, about a month maybe, we started to ship Torch-MLIR as part of the Stable Diffusion app. And so that has the entire pipeline from PyTorch. The latest PyTorch uses Torch-MLIR compile and then goes down to the Shark backend, Shark and EV backend. We've been continuing to improve the ergonomics for end customers, our end users. And so a big ask was training and fine-tuning. And so we've added both the Stable Diffusion training and Stable Diffusion fine-tuning. Vivek here will have a little video to demonstrate how it's working. There is something called LoRa, which is a way to do fine-tuning of Stable Diffusion where you keep the original graph constant, but then you have a smaller trained graph that's only like 30 or 40 megs versus like the original size of like 6 gigs or something like that. That makes it very easy to make like, very fast training of, multiple data sets, but then you don't, as they call it, you don't have catastrophic failure trying to train with 5 or 10 images and you lose your original quality. So that's a very popular fine-tuning mechanism in the community right now. And so we have someone who's working on that, and I think have some good results coming. It's based off of the same fine-tuning work that Vivek is doing. And then Prashant has been adding LLaMA support. LLaMA is the new quote-unquote open source model. You can get it. You can get the weights if you fill out a form. But the quality of the LLaMA 65B seems to be better than the OPT 125B or the Bloom 175B. So a really good model, or a really popular model if you have the weights. So Prashant has been loading those. I actually this morning he updated saying the loading is complete. It's on his branch and he'll be upstreaming it. I think it requires complex DTAG support, and he'll keep chipping away at like adding those ops so that we want to try and push Torch-MLIR to be in the forefront like SOTA models. So it's not just ResNet and MobileNet kind of like things that you can lower. We want to be like, as models come out, we want them to be working on Torch-MLIR as soon as possible, and ideally, eventually, people will also be using it in their research flow, and we can fill in the gaps of whatever is required for taking us to that level. But the first step is, the models show up. We should be able to get it in the order of days. And another one that I forgot to update here is ControlNet, which is a new. If you haven't seen any videos of that, it's a very fascinating way to control stable diffusion image generation, where you can use segmentation, mask out like what parts of an image are sky, ocean, and then you let stable diffusion generate different aspects of it within that segmentation or with human pose. So you can have someone in some particular pose or some stick figure in a particular pose, and then you can generate random, based on your prompt, people or animals or whatever else you want using that particular pose. So it's a combination of like traditional CV or other models combined with stable diffusion. And so we have that also working. So if you use the latest stable diffusion app from Shark, you'll have ControlNet like features, which again are state of art for stable diffusion. So we're going to continue pushing that, and everything we ship is from Torch-MLIR. Like there's no like we want to try and make the core Torch-MLIR code and everything contributed straight in there, so that it can enable us downstream in Shark, but anyone else also who's using Torch-MLIR to get the benefits. Any thoughts or questions? If not, I'll let Vivek show his little demo here, or we can show at the end, however it works, so that you don't have to interrupt the recording. But any thoughts or questions?
Hi, yeah, this is really awesome news. Thanks for all your contributions with this. Regarding the LLaMA workload, how did you guys deal with the fair scale code in there? Because I know there were issues getting that to trace with Torch script, and I think Dynamo just ended up splitting up into over 100 networks.
Prashant, you want to answer that?
Yeah. So basically, in the fair scale script, you'll find that it is a parallel implementation of linear as well as embedding. So you can just change it with nn.linear and nn.embedding, and it will trace. The next thing is that now Hugging Face has support for LLaMA model. I mean, there is someone who has pushed it over there, so you can use that also. I mean, it doesn't have fair scale things,
Were you able to get it working with weights, replacing the nn.linear, like the real weights?
Yeah, with the HF model one. Yeah.
Okay, got it. Thank you.
Yeah, and I think Prashant's adding the code back. So here's a branch. Prashant, you can share that branch. I tried to update the model, the thing, but I forgot to update with your link. But if you need, you can just share it in the chat so that others can take a look at how it's done.
Sure. Yeah, I'll do that.
Cool. Any other thoughts or questions? Gokul?
Hi. Is it possible by any chance to share the torch.mlir file that you get as a result of tracing these models?
Yeah, I mean, it should, with his branch, you should just be able to use it, but we can help. Yeah, just, I think Prashant will have it. Prashant, if you have, so which model do you want? The stable diffusion ones, or?
Yeah, the stable diffusion and the LLaMA, if you can.
Well, stable diffusion, if you use Shark today, if you have a Windows PC, just use Shark. It'll show up as MLIR files in your local thing. It'll go through Torch-MLIR and it'll generate the latest version. but you can choose whatever you want, right? Like if you want different sizes, different shapes, all of that, and it'll generate the MLIR file for you on the fly. So, and
Yeah,
there's a text.
yeah. I actually tried the Shark repo, but like I think in my local environment, which is provisioned, right, I'm seeing some package mismatch error when I try to do the run of the setup script in the Shark repo.
Okay, if you just ping us on Discord, just jump on the Shark Discord and we'll help you sort that out.
Yeah, I did actually. I actually did ping on Discord. Yeah.
Okay, we'll follow up there then. Just add me over there at PowderLove, and then I'll try and we can resolve it. It should just be something, some environmental issue. But yeah,
Okay.
so you can get all the stable diffusion there. LLaMA is not yet in the repo, but hopefully in the next couple of days, LLaMA will be there. ControlNet is there. So
Yeah. I mean, the main intention of asking for the Torch.MLIR file is to just understand, like, how ops are lowered from the PyTorch side downstream, and also for us to understand how we should lower them further downstream to our hardware. Like, it kind of helps us understand the ops that are kind of used in the whole model, right? So it's just a quick view of that. So if you can just share the Torch.MLIR, I think that'll be great.
Yeah, definitely. Yeah, just ping me or Prashant on our Discord.
Perfect. Thank you.
Any other thoughts or questions, folks? One other workload we have demonstrated is Bloom. It's a little older, but sharded Bloom on even on one GPU. Again, via Torch-MLIR, we kind of shard the 175 billion parameters into 70 shards or something, and then we can run them on how many of GPUs you have. So worst case is one GPU, but we've tested up to 16 in one system. Again, that'll apply to LLaMA also. So we're just pushing the Torch-MLIR with state-of-art generative AI models. Cool. Any other questions, folks? If not, Ramiro, I'll talk to you.
Yeah. Cool. Yeah. Thank you for the updates. We can, if Vivek has the video ready, we can show that here.
Vivek, you want to demonstrate the?
Yeah. Just a second. So my screen is visible, I hope.
Yeah, I can see.
So here is the video. So I will share the link as well. Like anyone can just try it on their own system and produce the images. So here the training has started. So the font size is small, but you can see that I just entered the Hugging Face token and the training has started. It has just printed out the initial weights of the model before the training has started. With a flag, you can switch to the PyTorch path of the training or through the Torch Dynamo and the MLIR path. This is through the MLIR path. Now at the end, you can see it just printed out this updated weights of the model here at the end. Just a second. Yeah, here. So it says that the training process is finished. So I ran it for a limited set of iterations, and the weights that are being updated after the training is completed. And at the end, this is the image that is generated. So this is with 100 training steps. So originally it has been done for 2000 training steps. So due to some time constraint, I generated it for 100 training steps. But if we do it for the original set of training steps, it will give us the intended image. And like the weights, we have verified that are being updated from both the paths, and they are getting updated in the right direction. So this is it from the Torch Dynamo path, and the fine tuning is supported. And it's there in the Shark. You can just try it. You can just install the Shark and try this. Yeah.
Cool. And you mentioned this is using Torch Dynamo for the training?
Yeah, Torch Dynamo and then MLI, the Torch-MLIR, and IRI as the backend for runtime and compilation. like Shark. Basically, we have used Shark there, which does the compilation through Torch-MLIR and then runs it through hardware. And this is on CPU, like the CPU training.
Awesome. Yeah, that's really cool.
And I have posted the link in the chat box, so like you can go visit that link and try get the steps how to do that.
Great. Yeah, thank you so much for that video.
Yeah.
Cool. If there's no more questions about this, we can move on to Prashant's presentation.
Yeah. Hey guys. So this presentation is about running float 16 graphs via PyTorch CPU. So currently you can see that this is a half linear model. That means that the D type of weights present in the model is of float 16 type. And we are just doing a computation of, we are just passing the input to the NN linear module. So the input is again a float 16 type, and we have instantiated the model over here. And if we pass this, if we want to trace the model via torch.jib.trace, then it will currently give the runtime error as this multiplication is not present. The multiplication is not present for the half D type. So you won't be able to get the traced IR. If you can move to the next slide. So if you want to obtain the float 16 trace, what you can do is first you should convert the model to FP32. That is basically so instantiated model.float. It will convert it into FP32 retype. So all the weights that is present in the model will be converted to FP32 retype, and convert the input to also FP32 retype. And now you can trace the model, and it will give you give you the TOS script IR, because FP32 ops are present for CPUs. Now, what you can do again is we have to convert back the model to the trace model to half D type. So what this will do is this will cast all the weights that is present in the model to FP16 D type, and you just convert the input to input.half, and you just pass this to Torch-MLIR compile module with ignore trace shapes is equal to true. Now there is a catch over here, which I'll explain later on. So if you pass this model as ignore trace shapes is equal to true, all the shapes and D type that is present in the model will be dropped off, and tracing will be done with the help of input. So whatever input has, that will be the starting point of the tracing. So you have weights as FP16 D type, and now the input is also converted to FP16 D type. So the IR that will be generated, the lineage IR basically that will be generated, will have all the FP16 D types present in it. So currently this ignore trace shapes will not work like this, because we have to also, so in Torch-MLIR.compile API, we also have to specify that you have to use tracing to ignore trace shapes. But I think it should, it should be dropped off, because the users will be passing already trace models, right? So, and it should be, and we want to do the trace ignoring of shapes later on. So I don't know, but yeah, I can raise a patch for it. It's just commenting 2 lines. So
the issue right now is it gets traced again in Torch-MLIR.compile, and that causes the issue.
Yeah, exactly, and that will give an issue, right?
Yeah, we should be able to identify like if the model is already traced, to not do that again. Yeah, that should be fixable.
Okay. So, and now we'll look at why not use Torch jet script. With jet script, you can do the same thing without even casting and all, because it doesn't run the model end-to-end on whatever platform. So scripting works for simple modules, but for complex modules like Stable Diffusion, it fails. Also, we are using MakeFX to leverage the upstream decomposition, and MakeFX uses tracing, so this will again fail. So yeah, also to do this, we have to cast some of the operands to FP32T type. Like some of the reduction ops will actually give nans out of it will just overflow if we do it in FP16T type. So some of the ops like 8 and var mean operands have to be converted to FP32 and then casted back to FP16. So all the transform is present over here in the later link. So yeah, that's that.
Cool. That's very interesting. So when you do the like model trace of half and you look at the IR, it just changes every time the tensor gets used to an F16 in the graph.
Yeah. So all the weights will be casted to FP16 in the graph.
Okay.
Now you just have to drop the shapes and you just basically data flow on the input D type. So that will generate the correct FP16 graph.
Interesting. Does it let you run, if you just do model traced and you run that, does it let you run it on CPU just using PyTorch, or does it give you an error? Do you know?
Could you repeat?
So once you do model trace to half,
Mm-hmm.
and you then run that trace model just on regular PyTorch CPU, or does it give you a runtime error?
Oh, it will again give the runtime error.
Okay.
Okay. Also, we have been able to run compile on the fly for Stable Diffusion workload, and it's been running fine till now. We haven't faced any problem with 1.4, but currently we have issues with 768 thing. But yeah, for 512 cross 512 Stable Diffusion workload, everything is working fine, and we have
Cool. For the casting of the ops, do you use, is it Torch-FX transformations, or how do you insert that?
Yeah, so we use FX transforms.
Nice. That's pretty cool. Does anyone have questions about this?
Yeah, this kind of alleviated the need to have a CUDA card when you're running on like a AMD or Intel GPU, right? Like the original model is a CUDA one, and initially we had to export, and that required a NVIDIA card. Then using this, now it's fully agnostic. You're just doing it on the CPU, and then you can target any GPU or any accelerator in the backend, which makes it very powerful to deploy. It was a big deployment headache.
Yeah, this is pretty nice. I was wondering, it doesn't generate CUDA ops though, right? It's just CPU ops, but the input types have been changed.
Yeah,
So
it
that's
doesn't.
also, yeah, that's also pretty nice. Because then in Torch-MLIR, we just have to worry about those ops, and that's it.
Yeah. Initially, we were trying to go down the let's do CUDA and export and do end-to-end tests with GPU ops and all that, right? This keeps it slim and no GPU specific stuff, because the half support was the biggest one that we didn't have, and now once we have this workaround, now all the models we can have.
Yeah, I would have. Did you not run into issues in Torch-MLIR though for, this op doesn't have the refined types information for float 16 and so on?
So we haven't got into any issues with FP16 refined types. Yeah.
Interesting.
I think this work came out. I think Antonio or someone suggested a few weeks ago, like a couple months ago, like, hey, you can trace it on F16 on CPU, and then we kind of went and explored this. Prashant did this.
Cool. Yeah, that's an interesting trick. Are there any questions from people? Cool, awesome. Well, thank you, Prashant, for presenting on this. Yeah, now the final slide is our health checkup, which we've never gotten a response on, so we'll see how it goes this time. Yeah, if you have any feedback on, whether you've seen issues with CI stuff, or you wish reviewing was faster, or I don't know, debugging experience in Torch-MLIR is not as good as it could be. If you have any feedback on that, yeah, do let us know.
So, no questions. I do have one comment on the CI. There is one weird Git issue that we're tracking, where occasionally Git trips over itself if you're doing a shallow clone. So Shay and I are looking at enabling, default deep clones to work around that issue. It's just when you have massive parallelism and you do shallow clones, you get some index.lock issues. Yeah. Hopefully, you shouldn't notice it. Maybe we'll keep an eye on it and make sure it's fixed.
Okay. Yeah, and the issue that I had mentioned about the unable to rerun the CI, it did get fixed once they force pushed the patch again. So it must have been some weird, GitHub thing.
Yeah. There's some weird GitHub, like there's one build job that's still running for like 2 weeks, according to it. So maybe it doesn't the shark repo, but yeah, some weird transient stuff on the GitHub stuff does happen occasionally.
Yeah. Cool. Okay, so if there's no feedback, that's pretty much it for the presentation. If there's any questions or topics that people want to bring up to discuss, now's a good time to do it. All right. Well, thank you everyone for coming to the meeting, and have a good rest of your day.